In this demo, we're going to pull together a lot of the things that we've been learning in the last two modules, and also we're going to be looking at what we've discovered in this module. So my view at the moment is IntelliJ, which is a development environment by a company called JetBrains, and the community edition is available for free, and the environment has got very good support for HD Insight. So what we're going to be doing in this demo is showing how we can go from testing something locally in Spark with a machine learning application to then deploying this onto the cluster. So if you look at the code base here, at the top of every Scala file we'll always define a package, and this package is com Microsoft Learning EDX, which defines which defines a canonical unit to show where in the object hierarchy our class ML main is. So we've created a class called tweets, which in Scala is a case class. We don't need to define a definition for this. So this particular case class has an ID, it has a double, it has a source of the message, and it has a string. You should be very familiar with this now, because we've done something similar in the previous modules and through data frames as well. So whenever we run this locally, we need to ensure that Hadoop tools have been registered. So so we've downloaded some Hadoop binaries, and we have to set a system property to ensure that it knows that that we have a copy of Hadoop locally. Otherwise, we'll error. Then we create a Spark conf and a Spark context drawn from this. So we set our application name in our Spark conf, and we set our master, which in this case is local 2. Now that says that I want to run this locally with 2 threads. Now from the Spark context we draw a SQL context so that we can manipulate data frames. Now the first thing that we'll be doing is we'll be taking the training tweet file, and we'll be training our machine learning algorithm logistic regression, as we've been doing, and we will push each of these file values into the tweets class and then turn this into a data frame. And then right about now you should be quite familiar with this code. So we'll tokenize, we'll hash and turn the words into features, then we'll use a logistic regression algorithm, set up a pipeline, and we will do a model fit here, so that we take a model from our training set. And in this case what we're going to do is actually write and save this model. Now one of the key reasons for using Spark streaming on Azure through HD Insight is by coupling Azure services. So in this case we're going to be using the Event Hub. And for this we've set up a temporary event hub just so that we can showcase, and we've got a namespace, we've got the name of the event hub, so this is a service bus namespace, we've got a policy name, we've got a policy key, we've got a consumer group which we discussed, we've got a partition count as well. So so something has to send on a number of partitions, and at the moment we're only receiving on one partition, and that's really just because of the limited resources that we've got available locally. And we also have to checkpoint, so every 30 seconds we will be persisting the state of the event hub locally. We create a streaming context, and we have a sliding window here of 15 seconds. Set the checkpoint directory. Now this is where things get a little bit interesting, because we will be looking at a clustered global variable called an accumulator, and an accumulator is one of the ways that we can store state across the cluster in Spark. So in this case we have an accumulator variable of total and an accumulator variable of current. So we'll be as we send messages through the event hub, we will be monitoring the total number of tweets, and we'll also be monitoring the number of current tweets that we know that we got right in our test case to calculate the number of percentages. So Microsoft has supplied a library that we can use, and this is event hub utils, and it allows us to create a union stream. So with our parameters, we could be running the streaming receiver on any one of the data nodes in Spark, any one of the slaves. And what this will mean is that these processes will, there'll be resilient processes which will connect to just one partition of the event hub each. So in this case, we're just connecting to one partition of the event hub, to partition 1. But in production, what we might do is connect to 8 partitions, given that our particular event hub has 8 partitions. And then what we're going to do is we're going to map the output of the event hub into the tweets. And what we'll see is that each of the tweets is then streamed through as a D stream, and we unpack this like we've been discussing, and we simply do a calculation which will keep the running totals in the accumulator across the cluster, and it will reformat the result so that we know specifically what the percentage of correct guesses are. So what we can do to test this locally is we can create a local configuration. You can see here that we call the ML main namespace, and we're passing the training tweet where this is on our hard drive, and we'll click OK there. Now one last detail that we need is we've created an event hub, but we actually need to send messages. So in this case we are going to be using an application that we've built called Tweet Pusher, and this will generate messages on the event hub, and it will also do this with some command lines that we can specify. So you can see here that we've got a latency of 0.1 seconds. We tell it the directory that we want to take our test tweets from, so this is on my desktop at the moment, and it will read this line by line, and then it will connect to the event hub. It has the credentials that you can see there, and it will keep sending messages on that event hub, and hopefully our application will be able to pick it up. So if we start this, you can see that it's busy sending messages now, and while that's going on, let's run this locally and see what will happen. So you can see in this window immediately we get a view of all of the things that Spark has to prepare for. And there's obviously a lot of content that's going on. It's doing a lot of things. It's very busy. But very soon it will start receiving messages. You can see there that already it's receiving these messages. So we know that we're pushing these messages out on the event hub, and now it's round tripping and receiving these locally. So within our window, what we should do is be able to see how the event hub has guessed the number of count. You can see here we've got 65.09% correct guesses. So we know that our application's working, and it's continually persisting the state in these accumulator variables. So in order to deploy this, if we stop this now, we can simply create an artifact by choosing build artifacts and clicking on build, and this will give us an artifact which we can then deploy to the cluster. So once we've copied that file to the cluster, you should see that we can run this using Spark submit command. So we need to tell the Spark submit command where the what the class is. We know this is COM Microsoft Learning EDX ML main. We need to tell it a master. So we've used Yarn client. There are two modes in Yarn. There's a Yarn client and a Yarn cluster. Yarn cluster will allow us to run this on something that's not the driver node. But for the purposes of what we're doing at the moment, what we really want is to just run this on the driver node. Then we use an executor cause here, and executor cause, we're giving it we're giving it 4. We're telling it that we want to run this application across 4 cores in the cluster, and we're telling it where the jar is. So we've copied this up locally, and what Spark will do is it will broadcast the endpoint across the cluster. So it will make this available, and all of the residual nodes will download that jar from the driver so that it can execute it. And we're passing in one parameter here. If you remember last time, we passed in the location of the training tweet CSV. So this is in WASPA, blob storage, and it should pick this up straight away. So if we click enter here, we should, you can see we've entered our software. It says EDX processing 1 arguments, and it's going to begin and start Spark now. So it's setting up some things on the driver node. It's registering all of the different executors, and soon what it's going to do is actually run the software. So if you remember, we have a set of messages which are continually sending on the event hub. So I think in this file we've got maybe 2,500 messages which it could potentially send. So there's a lot of content that our Spark cluster can pick up in the same way as our local application picked up. And what we'll find is that it's location agnostic. So in exactly the same way as we didn't really care where that we were running this locally, and the local application was receiving Event Hub messages because it connected, it used streams, albeit on a single partition, whereas this is on 8 partitions. It doesn't care whether this is running in the cloud or not. So let's get this message flow up a bit, and then we will stop to look at our cloud application just to make sure that that it's running all correctly. And you can see that we've got it doing a lot of work, and it's already started receiving the tweets, as you can see there, and it will be doing the similar calculations. So somewhere along the line we should be able to see the percentage correct guesses, and you can see on the screen that in exactly the same way we know that we've made 60% correct guesses there. So that's how you can take an application that you develop, you can run it and test it locally. It's performing machine learning, it's doing this through a streaming mechanism, and we can extract sets of results from this.